All right, let's just dive right into this. Welcome to the absolute ultimate challenge for all you cloud professionals out there who are gearing up to build the next generation of AI agents. Look, if you're an engineer, an architect, or a technical leader taking these exams, you already know the cloud landscape is shifting under our feet. We are way past simple chat interfaces now. We're heading straight into the era of agentic workflows and true intelligent automation. The stakes are incredibly high, and honestly, the margin for error in production is razor thin. So today's explainer is really going to put your readiness for that exact future to the test.
So we're jumping straight into the deep end today. Do you actually have what it takes to architect enterprise-scale AI solutions and crush the Microsoft AI-103 certification? You see, organizations everywhere are scrambling to adopt generative AI, but what they desperately need are developers who understand how to genuinely design, build, secure, and deploy these applications at massive scale. It's not just about making a quick API call anymore, right? It's about complex orchestration, rock-solid security, and making those really tough, real-world architectural trade-offs.
And that brings us to the Microsoft AI-103 exam. This is essentially the new gold standard for this era. It's Microsoft's next-gen certification specifically for developers building intelligent apps using Python and Microsoft Foundry. Think of it as a massive evolution of the old Azure AI Engineer path. But here is the major catch, and you really need to hear this. This exam demands true, real-world problem-solving. You literally cannot just memorize your way through this one. You have to know exactly how to handle Azure OpenAI Service, retrieval-augmented generation, vector databases, and responsible AI practices in actual high-stakes production environments.
Now, to actually conquer this beast of an exam, you need prep material that reflects reality. Fun fact, did you know most AI project failures actually stem from poor architectural planning, not bad code? Yeah. And that is exactly where cloudcertificationstore.com comes in. They offer the absolute best prep material out there, featuring over 600 scenario-based exam-style questions that are specifically designed for production-level cloud engineering. This isn't just basic trivia. This material is meticulously engineered to mirror the exact architectural decisions you're going to have to make when building AI-powered apps on Microsoft Azure.
cloudcertificationstore.com is pretty much your premier destination for affordable practice exam questions and super helpful free guides. But what really sets them apart? Well, it's their intense focus on detailed rationales for every single answer choice. They don't just hand you the right answer and walk away. They break down exactly why the correct answer is right, and crucially, why the other options would completely fail in a real-world scenario. They dive deep into cross-domain architecture, critical security implications, and even cost optimization, so you're guaranteed to build real understanding, not just scrape by with a passing score.
And you know, this expertise isn't just limited to Microsoft. Whether you're currently studying up for Azure, AWS, Google Cloud, or even NVIDIA certs, their full catalog totally has you covered. They offer these heavily discounted multi-cloud bundles covering machine learning, artificial intelligence, and agentic AI business solutions. It's basically a massive hub for serious cloud professionals who want to build out a robust cross-domain architecture practice.
Okay, enough talk. Let's actually gamify this a bit. I'm going to hit you with some rapid-fire practice exam questions pulled directly from the AI-103 study guide over at cloudcertificationstore.com. We are going to test your knowledge on Azure Foundry, AI agents, and complex security right here, right now. So get your mental scratch pad ready and lock in those answers.
All right, question 1. Imagine your company is building a customer support application in Microsoft Foundry. Now, this application must answer user questions using your internal policy documents. It absolutely has to include references back to the source content, and it must drastically reduce unsupported model responses. But here's the kicker. Those documents are updated weekly, so your solution must avoid embedding stale knowledge directly into the model. Just think about those exact constraints for a second.
So, what's your play here? Do you go with A, implementing retrieval-augmented generation using an indexed knowledge source? How about B, actually fine-tuning the language model with all the policy documents every single week? Maybe C, cranking up the model temperature and adding a prompt that explicitly begs the model to be accurate? Or D, relying on a small language model without grounding just to reduce variability? Lock it in.
Okay, let's break it down. The crucial point here is understanding how these models actually access dynamic data. The correct answer is A. Implement Retrieval Augmented Generation, or RAG. Why? Well, because RAG dynamically grounds each response in current,
indexed content, rather than relying on static, pre-trained knowledge. When those docs update every week, you just re-index them, you don't have to retrain the whole model. Plus, it perfectly supports returning those source references we needed. Now, if you guessed B, remember that fine-tuning is for adjusting model behavior and tone. It's terrible for dynamic data. Imagine retraining a massive model just because HR updated the vacation policy on a Tuesday. No way. Plus, it won't automatically give you those required citations.
Awesome job if you got that one. Moving right along to question 2. A development team is creating an AI agent in Microsoft Foundry to help employees submit IT service requests. This agent has to remember the conversation, successfully call an internal ticketing API, and retrieve specific troubleshooting steps from a knowledge store, all before it actually creates the ticket.
So, which design is the winner here? Is it A, a stateless chat completion flow? Perhaps B, an agent that combines conversation memory, retrieval, and function calling tools? What about C, a batch document processing pipeline? Or D, a standard text translation workflow? Think carefully because this one really tests your fundamental architectural patterns.
If you locked in B, you are absolutely spot on. An agent combining conversation memory, retrieval, and function calling is literally the only way to meet all these requirements. The memory handles the multi-turn interaction, so the poor user doesn't have to repeat themselves. The retrieval seamlessly pulls those troubleshooting steps, and function calling cleanly integrates with external ticketing APIs. If you chose A, a stateless flow, well, the model essentially has amnesia after every single message. It just cannot preserve the details needed to create an accurate ticket. This right here perfectly highlights the monumental shift from simple chatbots to true agentic workflows.
All right, final rapid-fire question. And this one is specifically for all my security architects out there. You want to deploy an Azure AI solution. Your security team rigorously requires the app to access the Microsoft Foundry project, Azure AI Search, and storage. But you absolutely cannot store client secrets in configuration files or source code. You need pure keyless authentication.
How do we implement this? Do we choose A, storing all service keys in source control and just restricting access? B, using one shared administrator account for everything? C, throwing all the credentials right into the user prompt so the model can securely select the correct key? Or D, using managed identities and role-based access control for supported Azure resources?
And the answer is D, Managed Identities and Role-Based Access Control, or RBAC. Managed identities completely eliminate the need to store secrets in your code, your pipelines, or your config files. Azure just manages the identity natively, establishing true least privilege access. And please, whatever you do in the real world, do not choose C. Putting credentials in a user prompt is wildly insecure and exposes your enterprise secrets directly to the model workflow and your internal logs. That is a one-way ticket to a very uncomfortable meeting with your Chief Information Security Officer. Managed identities keep your enterprise secure and fully compliant.
So, how'd you do? Did you ace them all, or maybe miss one or two? Either way, to consistently nail questions like these and actually conquer the AI-103, you need to follow this exact methodology. Prepare, practice, pass. Prepare using comprehensive free guides. Practice with realistic, scenario-based exam-style questions that actually test your rigorous architectural reasoning. And finally, pass your exam with absolute confidence because you genuinely understand the underlying concepts rather than just memorizing a list of facts.
Because earning this Microsoft-certified Azure AI App and Agent Developer Associate badge, well, it requires true mastery. It demands a really deep understanding of real-world architectural trade-offs, intricate cost optimizations, and strict security implications, exactly like we just saw with managed identities and RAG architectures. It's about fundamentally knowing how to integrate Azure AI services safely and effectively into existing business processes.
So head on over to cloudcertificationstore.com to grab those exam-style questions, study materials, and free guides to guarantee you get it done certified. But hey, the ultimate question I want to leave you with today is this. As AI agents move from being simple chatbots to fully autonomous systems running entire enterprise workflows, will you be the engineer managing the legacy systems or the architect building the future? Keep learning, keep building, and I will catch you in the next explainer.